Okay, so this is for a hyperbolic paraboloid. It's just a more in-depth example of what it is in SolidWorks. So I created this hyperbolic paraboloid using two skew lines. I found it just easier to do it this way rather than trying to calculate a proper square hyperbolic paraboloid. So this model shows a few things. It shows the elements, it shows the plane directrix or director, and how the plane director affects the elements. So I'm going to turn on. So I made the plane directrix surface and made it transparent as it is a plane. You see that plane director is the place where it starts the element. Then as you move on, you can see the plane director moves forward. I just picked an equal spacing of like I think 50 millimeters every time. So moves forward 50 millimeters every single time. Like this until the end. So every time the plane cuts through, an element is formed. You see at the beginning and the end I highlighted in blue, and here is where I show the elements. Okay, so the elements are now in place in the plane directrix, in the hyperbolic paraboloid, sorry. So I can hide those again. You can see that it makes a straight line through from one side to the other, and it's resting on the surface. Now to show how it looks. Oh, I did the wrong thing. 2 seconds. Well, you can look at it this way, as a skeleton without the surface on it. You can see the curve easily here. Like the elements create this curve. You can see that if you zoom in closer, you can see that it's kind of jagged. But the more elements you have, the smoother of a curve you'll get. So if I turn the boundary back on, you can see that the curve is much smoother as the surface autofills. You can see that there's no dips. And you can also see, there we go. As I pointed out this way, you can see the dip in the disc here. But if you look at it from the other angle, you can see that it is also rising. See it in the other model, the one I made of string. So this one here. This was made for a previous lab. So see that I made this came with it. You can see the dip here, and then if you can see the underside from this side, you can't because of the paper, but it has the opposite happening, which is what this cutout shows. So it has the dip, and then it has the rise. So this model shows the elements, and it shows the surface and how the amount of elements affect the curve, and how the plane directrix here has an effect on the elements. So it is they are all parallel to the plane directrix as the planes move forward all the way through. And that's how you get your elements. So they're all parallel from your plane directrix. Thank you.